Hello, good evening, everyone. Can you all hear me?
Yeah.
Great, thank you. So I think we can start. I don't know how many students will be joining me tonight. So probably we will get a few more later. But as we, plan to start at 7:30, that's just the start. Let me share my screen with you guys. So you guys don't have to turn your camera on. And if you have questions during the session, feel free to type it in the chat, or you can leave the question to the end and ask me directly, okay? So you can see my screen, right?
Yes.
Cool. Okay.
So we're playing Kahoot.
Yeah, we are going to do something interesting. Hopefully you guys will like it. Let's see. Okay, let's start. So you need to have a second device to join the Kahoot. Oh, sorry guys, my bad.
I'm tiling my screen so that I can see both windows.
What do you mean?
Like there on a Mac, there is a choice to like put one thing on the side of the screen and another. That's what I use.
If you have a big screen, if you have a kind of relatively small laptop, that might be too small for you to see my questions.
Well, I'm using a projector, so I guess.
Wow, cool. You're a professional. I'm going to record this session, so this is why I recommend you guys now turn your video on. Seems like we have 12 students. I think we just need to have one more. Okay, maybe we can start. It seems like there's no more students joining. Oh no, all right. We haven't started yet. As many of you probably the first time to join a class or a prep session with me. So I would like to, give you a very brief self-introduction. I'm Dr. Chen. I'm a, chemistry teacher working in a STEM-focused private high school in Princeton, New Jersey. Actually, this kind of prep session for the local exam was held by me pretty much annually in the past maybe 3 to 4 years. So besides my teaching in the school, I was also very actively involved in a lot of volunteer work about Chemistry Olympiad with ACS. Just to give you a few examples, I am leading the annotation exam solution project, working with a big group of volunteers from all over the world. We annotate the local exams and the national exams. As you probably see, many of them are published in the ACS website. Just want to give you a quick show. So if you don't know about this, here, if you see the solution links, we published the most recent 5 years of local exams. Why I say the most recent, well, we didn't include the 2021 because those 5 years was published in 2020. And for the national exam, we also published, the most recent 5 years. So we are working on the other years. I hope, before the national exam this year, we can, post another maybe around 15 years of annotations for both local exams and the national exams. So we are still, working on this. Another, volunteer work I participated is the, what that called? It's called the USNC webinar. Those webinars, I think they are very helpful for you to prepare the Olympia. So you can watch the recordings from the website. Just search in Google USNCO, you will be guided to the link from the home page. I was also involved in the USN's coaching session. I think later I will give you a little bit introduction about one of the session I participated last year for organic chemistry. Yeah, that's pretty much about me. If you want to know more information about me, you can go to this website. This is my personal website. I think you can find a little bit more information about me. It seems like we got one more student. So I believe you can still join the Kahoot link by using the pin code here, okay? Oh, before we start, I want to briefly share with you the stats of the local exam last year. I think probably this will be the only year with a real meaningful and reliable stats, because this is the only year most students, took it online, right? In 2020, I would say about half students took it in person, another half, took it, online. So the data is not very complete, right? So here, the 2021 is probably the only year. And this year, I believe most students will still take it in person. Maybe a few of them will, take it online. So as you can see, the mean last year is 30, right? 50%. That means, it's still a relatively challenging exam. If you can score higher than 30 in the recent few years of a local exam, when you are practicing, I would say is a pretty good result. Yeah, I got a question. What is the score I need to get to qualify for national exams? This is a question with no answer, because I don't know, because the USNCO use a very different system. It's based on nomination, right? So
and also I think like maybe the top 1,000 people get to nationals.
Yeah, top 1,000, pretty much top 1,000 students.
So it depends. Like if even the best students got 30, then the people who got 30 are in.
You're right. So
yeah, but like I meant in the past years, like what normally is the score for the top 1,000 people?
It can be very low, to be honest, because first, the nomination is based on both local sections and also your high school. That means first, you need to be higher than the cutoff in your local section, but each local section have a different cutoff, right? Secondly, you need to be the top 2 students in your high school. So in some school, the cutoff probably is 59, maybe 60, especially for those very strong STEM-focused big public high schools, right? That's possible. But for some, local district, maybe the cutoff is, let's say, 35, or maybe even lower. I can only share, the local section I am in. The cutoff in the past few years is around 40 to 42. But I know some local sections definitely have much higher, cutoff than this. So this is a question with no answer. If you really want to get some, reliable data, the best way is to contact your local coordinator if he or she would like to share with you. I do know they have the data, but I'm not sure whether they would like to share it or not.
Okay, thanks.
Yeah,
where can I find my exam, coordinators, contacts for that?
Oh yeah, definitely you can. Let me quickly show you. In case this is also a question for some others of you guys. So you go to the USNCO homepage, and then you click coordinator, and then you can find your USNCO coordinator by typing your zip code. For example, I'm in 08540. So this is the name of my local coordinator. And if you click the contact coordinator, it will guide you to an email. And actually the email is not directly sent, I believe it's not directly sending to the coordinator. It will be forwarded to the USNCO and the CC, the local coordinator. Probably, I'm not exactly sure. Yeah. Okay, just want to give you a sense. 30 is the mean of the local 2021. This year, probably we cannot get such a big data because as you can see, probably more than 10,000 students participated in the local exam last year online, right? Completely online. Before we start the Kahoot, I want to give you, a few pieces of suggestion based on my experience, my many years of experience, working with students. Because, this is pretty much the last few weeks, right? Some of you may have a little bit more time if you, will take the exam in the middle or even the end of March, but some of you probably will take it in the early March, right? So this is why I also choose this time to give the prep session. First, if you have time, try to solve every single question in the local 2016 to 2021, basically the recent 6 years of local exam. Why this 6 years? Because they are much harder than the early years. It's not really meaningful to work on the older years unless you have plenty of time. And actually, if you have plenty of time, I would suggest to keep work on the national exams rather than the older years for locals. They are way too easy compared to the most recent years. The second one, check your work with the annotations published in ACS, as I just talked about. This is a project, led by me, and we have some good work, published here. I believe, I would say 99% of the annotations are in good quality. It has been, proofread by several rounds by by me and the other proofreaders, and also kind of published online for about 2 years. So I believe we already got all of the bugs. Yeah, regarding the time limit when you solve the questions, I will say it will be the best if you can time yourself. Although the local exam, typically, the time is not a big issue. You have 110 minutes for the local exam, right? So typically, for most students, I would say time is not a big issue, but giving yourself a time limit is still, very useful and practical to improve yourself. The next one I would recommend is after you reading the annotations, if you still have a question you do not understand, right? What should you do? You can, talk with your classmates, your teammates, or your teacher. If you have no sources like this, you can find me. I'm very happy to help you. And actually, in the past years, every year I kind of discussed a lot with a lot of students in Discord or in other different platforms. So where's my Discord server? This is my personal website, easy to remember. It's called dicho.us. So you just go to more. There is a Discord link here. Okay. Yeah, I'm pretty much online every day. So if you have any questions, feel free to ask in the server or directly ask me. I recommend you ask in the server because the other student can also see our discussion, right? We can benefit more students. Yeah. The next one, I kind of summarized an unofficial syllabus for the USNCO, which is listed in my website as well. It is under the USNCO learning objectives. So based on the 10 topics for the local exam, as you can see, I put several learning objectives for each topic. I will recommend you to go over this list and make sure you understand all of the points, all of the learning objectives you are supposed to know. So there is a little bit instruction here. And then for the organic chemistry part, this is kind of beyond the scope of the AP Chem. So you might need to take some extra time. And by the way, there is a very good website for you to use. It was made by Andrew Ni, who is also a USNCO kind of alumni. He graduated maybe 2 years ago. So he made this website and it is still online. So it kind of make all of the USNCO questions into an online quiz. For example, if we click, one topic, let's say stoichiometry, and then you can try to pick up an answer. If it's correct, it will show you a green color. If it's wrong, it will show you a red color. And then if it's right, and then you can click the solution, it will directly give you the annotations we made. So I think this is a pretty good way for you to do some, self-study. Maybe, you can also work with your friends, you guys can work together, right? Share a screen or, sit together, right? I think it would be more interesting than just, working on the questions. But this is a different way, right? Time yourself, take it like a mock test. Definitely it's practical and useful. But after you finish all of the questions and you still want to review some of them, this can be helpful as well. Because if this question, let's say the first question, I have no problem, you can just, delete it. So this question will not be shown in the list anymore unless you refresh the browser. Okay. The last, idea here is do some quick study for fundamental organic chemistry if you haven't done so. I know organic chemistry is always a hard part for a lot of students to prepare for the local exam, right? So here I recommend a material summarized by me, actually is also published in the ACS website. Let me see, where is it? Go to the exam and we have the US Census support programs. Guys, feel free to take some notes, okay? Because I didn't put this link, directly in the Kahoot, okay? Go to the exams and then click this USN support programs. And then you will see the coaching sessions. Unfortunately, the USN support program is not one of the tabs here. You might need to go to the coordinators to find it, but it's kind of hiding in somewhere. Yeah, it's here. It's the 2021-2022 USN support program under the coordinators. And you go here, and then you go to the coaching sessions, and then you will see the coaching tutorials from last year and from this year. I think they are all very helpful. The one I would like to recommend you is this one, is the material or the handout, or you can see the lecture notes I used last year for organic chemistry and biochemistry. The first part is not provided by me, it's by another coach. So the one starting from this page until the last page, there is around 14, 15 pages of some, very summarized fundamental organic chemistry. I think I listed all of the most fundamental items, and maybe you can say the most important or the highly frequently assessed, points in the local exam. I can only say local exam because national exam is getting, more challenging and assess you more advanced reactions for organic chem. So you can take some time to go over this lecture notes. I believe it should be enough for you to prepare the local exam. So when you are working on this, if you have any question, just let me know in Discord, okay? How about I put the link here, guys, in case you guys would like to get it. Copy the link and I will put it here. Guys, you may need to click it right now. Otherwise, when we end the Zoom session, the link is gone, okay? And how about I also put the learning objective here. Anything else I want to share with you? I think that's pretty much. This is about how to find the local coordinator. Let me also put this here. Yeah, that is the 3 links I just mentioned. Okay, I think we probably can start. A few, things before we start. First, those questions are written by me based on the local 2021. There's no calculation-based problems because that's too time consuming. We don't have enough time to finish everything today, right? The next one is those problems are not aiming for national exam. So that means they are not too hard, okay? The time provided for each question might not be enough for you to fully think about the question. So it might be, too short for some of you. There might be some typos and mistakes. I hope I kind of corrected all of them. But if there is still, a few, I apologize in advance. Okay, guys, let's get started.
Yeah, I clicked the wrong one too fast. Silicon is the most abundant element in the Earth's crust, but not the most abundant metal.
Sorry, guys. Thank you. Yes, the one you just mentioned is the original question in the local 2021, asking which element is the most abundant. Here, I slightly revised this question, changed the element into metal. So I successfully, tricked all of you. So metal, right? Silicon is not a metal. It's a kind of semi-metal, or you can say it's a non-metal. But it is indeed in between the metal, non-metal boundary, right? It's a semi-metal, common used semiconductor. So the most abundant element is not silicon, it's oxygen, okay? Oxygen is number one, silicon is number two, and aluminum is number three. So I think this is fair to ask, what are the most abundant elements in the Earth's crust? So the answer is C, aluminum. Let me know if you still have any question, okay? It seems like we didn't get a good start. Let's continue. For the student who just joined, please join the game by using the pin code in the right button. Wow, this is also a pretty hard question, guys. Surprising, right? The highest molar solubility in water, we know water is a polar solvent, right? Based on like dissolves like, we definitely want to choose a polar solute or a polar gas, right? So we can eliminate C and D easily and quickly because both of them are non-polar, right? For A, carbon dioxide, as you know, is a linear structure, right? 2 electron domains, 2 CO double bond, right? So it's linear. So the solubility of carbon dioxide in water actually is not that high. You might question me, how about the Coke, right? We know in the Coke there is a lot of carbon dioxide dissolved, right? But please remember that case is under a very high pressure. So this is why if you swirl the Coke bottle and you uncap the bottle and then the gas is immediately released, right? But at the 1 atm irregular atmosphere pressure, the solubility is relatively low. Actually, it is higher than it's supposed to be because based on the non-polar property of carbon dioxide, it should be very low. But actually, there is a reaction between carbon dioxide and water.
Carbonic acid.
Exactly. It will produce carbonic acid, okay? So which will make the solubility slightly higher, but it's still very limited. So sulfur dioxide, as you know, if you draw the Lewis structure, right, you will see there are 3 electron domains, right, surrounding the central sulfur. So the molecule is bent or V-shaped. So this is a polar molecule. So 1 liter of water can dissolve 40 liters of sulfur dioxide. So it's relative, soluble. Did I make it clear, guys? Okay, cool. Pretty good. First, let's try to eliminate some of them. But cobalt chloride is a very typical pink compound used in AP Chem to demonstrate the Le Chatelet principle, right? So another color, related to this is the blue one, which is the complex made by cobalt with the 4 chloride. And the pink color is made by the cobalt 2+ with 4 water molecules or 6 water molecules, right? So basically this is pink, this is blue. So we can use this color change to demonstrate the Le Chatelet principle, right? So we can eliminate C. Lead iodide is a very bright yellow precipitate. This is also a common used, experiment in AP Chem. Barium chromate. We know chromate is yellow. This is kind of a yellow ion, right? A yellow ion. So barium chromate, we believe, is supposed to be yellowish or maybe reddish, because depends on the difference of the cation, the color can be slightly different. So the only one is colorless is the silver nitrate. I believe if you use silver nitrate before, you should have some impression about the colorless. But how to briefly justify this? Nitrate has no color, right? And silver plus has no color. How do we know? Silver plus is similar to zinc 2+. They have a 4Nd electron configuration, is D10. So the color of the ions, especially for most of the transition metal ions, the color is caused by something called DD transition. Basically, the d orbitals have different energy, so they are split. So if the electron transit from the lower energy level to the higher energy level, it will absorb the light. And if this kind of energy gap is in the visible range, and then the ion will show the complementary color of the light, which is absorbed. Does this make sense to you? Let me know if you have any question, okay? But for D10, since all of the d orbitals are fulfilled, so there's no space for the electron in the lower energy level to transit to the higher one. So this is why for zinc 2+, for silver 1+, maybe you can further extend to cadmium 2+, mercury 2+, copper 1+. Yeah, all of those are kind of, D10. So they have no color. But it doesn't mean the precipitate has no color, okay? I'm talking about the ions in solution, okay? The ions in solution. For example, iodide does not have any color, but the lead iodide is yellow. This is a slightly different story because it's a precipitate. And the silver iodide is also yellow, right? So it seems like the iodide compounds or the iodide precipitates are yellow, but I cannot say for all of the iodide precipitate. Just give you 2 examples here. So I think, typically in the AP exam, in the local exam, the color which will be asked will not be too scary. It should be some commonly used chemicals in the AP Chem, experiment. For example, another common used one is permanganate, right? You all know it's purple, right? Okay, cool. Not bad. This is a little bit challenging. The reaction between chlorine gas with sodium hydroxide actually is like this. It's a disproportionation reaction. So obviously it's a redox. Disproportionation means the oxidation number changed from a medium level to a higher one and a lower one at the same time, which means the element with the oxidation number change is the same element. So the chlorine here changed from 0 to -1 in the chloride to +1 in the hypochlorite, right? This actually is the active ingredient of the bleach because it's a super strong oxidizing agent. So this is how the bleach, works. It can oxidize those kind of dyes with color and, bleach the color. So B is wrong, A is correct. So the solution is colorless because both of these two anions are colorless and the sodium plus is also colorless. And the solution will not be darker, although chlorine does disproportionate. Let's continue. Oh, for the new student who just joined, we are playing a Kahoot game. Feel free to join us by using the pin code in the right bottom, okay? Ah, I see. This is a very typical error analysis question. I believe there is one question like this in the local exam every year. So the answer, and that's how about we talk about then one by one, all of the 4 options. For A, if the solid is spilled, the molarity should be lower, right? Because not all of the solid is dissolved in the volumetric flask. You guys know what is the shape of a volumetric flask, right? It's something like this. And then there's one mark to show you the volume, right? The volume is typically, let's say 100 milliliter, 250, 500, or maybe 1000, depends on the size of the volumetric flask. So A is wrong. For option B, water is added over the mark and then taken away using a pipette until the mark. What do you think? How does this affect the results? Does it really affect the results? The answer is yes. If you add over the mark, now say the water is here, and then you take this much water out, it seems like it does not affect the result. But actually to realize the dissolution process is pretty fast. So when some water is added here, there is already some solute transfer to this layer. So if you take this part of solution out, the remaining solid actually is less than it's supposed to be, right? Or should be. So the molarity is getting lower. For option D, the weighing paper is not tailed when trying to measure the sodium chloride. This will be a big problem because if you do not tail the weighing paper, that means the mass of the weighing paper is counted into the mass of the sodium chloride. That means when you measure 2.92 grams of sodium chloride, there is less than the actual mass of the sodium chloride is less than that. Does this make sense to you guys? Okay, let's have a look at the C. The meniscus is kind of, the weird shape of this water level. It's like this, right? For water, if it's mercury, it's a different story, right? Due to the capillary effect. And now say the mark is supposed to be here because we want to make the lowest place of this meniscus the same as the mark. But now if it is red below the eye level, the case will be like this. So the mark is here, and then your eye is here. You are observing in this direction, and you think it's already kind of, the level we need, but actually we need to get a little bit more water into the volumetric flask. So this is why the molarity is higher. So guys, for questions like this, it's relatively hard to prepare. But every year you will get a different scenario. But what I can, recommend you guys is to analyze each option one by one and try to get a clear conclusion, right? If you can eliminate some of them, that will make your, selection easier. But there's no other good method. And the most useful way is to get the chance to work in the chemistry lab, right? To get the very direct, sense of each experiment, at least the common used, experiments. So this is why I always say, taking a year of AP chemistry should be pretty helpful for you to prepare for the USNCO, especially from the perspective of experiments. A lot of you chose B, covalent bond. Carbon-60 is a big molecule which is made by 60 carbon atoms. Let me show you a structure, carbon-60. It's like a soccer ball, right? So this is the carbon-60. So they are connected by covalent bonds. But when you need to subline the carbon-60, you just convert the carbon-60 from solid state into gas state, right? That means you just need to make the distance among the carbon-60 molecules further, right? You don't need to break any covalent bond in between the carbon-carbon atoms. So this is why you just need to overcome the intermolecular forces rather than the covalent bonds. Does this make sense to you guys? So carbon-60 is a big molecule, but it is a molecule. It's different from sodium chloride. It's different from silicon dioxide or diamond. They are directly connected by the covalent bond. But here is the atoms in the molecule are connected by covalent bond, but the molecules are interacted with each other by the London dispersion forces. Because this is a highly symmetrical structure, it is supposed to be non-polar. Once again, if you have any question during the process, feel free to type your question in the chat or directly ask, okay? You don't need to raise your hand. You don't need to, get permission. This is a hard question, I will say. I put the title into explanation of unexpected results. Based on my observation, I think there's always one question like this in the local exam, at least in the most recent years. So how to work on questions like this? We don't know. We never saw something like this before, right? But based on your understanding and your knowledge, I think you will figure out which one makes the most sense, which option can explain the unexpected results of experimental observation. So here, the calcium chloride solution and sodium chloride solution, they have the same molality. The lowercase of m represent the molality, right? So theoretically, because each mole of calcium chloride can dissociate into 3 mole of ions, right? 3 moles. But each mole of sodium chloride can dissociate into 2 mole of ions. So theoretically, the melting point depression of calcium chloride is supposed to be 1.5 times of that of the sodium chloride. Now this makes sense to you? Because melting point depression is a colligative property of solutions, which means it's only related to the number of particles in the solution and not related to the identity of the particles. Oh, sorry. Did I make the first part clear? A very brief explanation to the question itself, and then we can go over the options. But right now, it is more than 1.5 times, right? So if we pick up A, calcium 2 plus has a stronger interaction with chloride than that of the sodium plus and chloride. This is actually something called Van 't Hoff factors, because we know not all of the ions are completely free. They are hydrated by water, but still, since they carry the positive charge and the negative charge, they still have some interactions with each other, right? So if calcium 2 plus has a stronger interaction with chloride, that means the free ion number in the calcium chloride should be smaller than 1.5 times in the sodium chloride solution. Does this make sense to you? Because they have a stronger interaction, which will make some of the ions not free moving anymore. That means it will decrease the number of the particles in the solution. So A cannot give you a good explanation to the results. If the A is the answer, the observation should be less than 1.5 times. Although A is a correct statement, but it's not a good way, it's not a right way to explain the observation. So for B I think is unrelated, right? The dissolution, exothermic, endothermic, is not really related to this. Option C, calcium 2 plus has a stronger interaction with its hydrated water molecules than sodium plus does. This is also a correct statement. It's correct, but calcium 2 plus, first, it has a higher charge. Secondly, it has a smaller radius. So the ion dipole interaction in calcium 2 plus with water is stronger than that in between sodium plus with water. And this actually is the correct answer. How to justify that? If the calcium 2 plus strongly interact with the hydrated water, you will see those waters are not free moving anymore. Basically, when you calculate the molality, right? The molality is the moles of the solute divided by the mass of the solvent. But actually, this solvent is supposed to be free-moving solvent. So if the solvent is kind of fixed by the ions, the cation or the anion, those waters actually are not counted anymore. But obviously here, this is not really clearly explained in the background of the question. So you need to pick up the most reasonable one. So C is the one. And D, calcium 2 plus can dissociate into more ions. this demonstrates why it's supposed to be 1.5 times, but it cannot explain why it's more than 1.5 times. So C, although it sounds not like a very clear answer, but it is the reason behind this question, because the calcium 2 plus make more water molecules not free moving and kind of increase the molality of the solution because the mass of the free water is decreasing. Any question for me? This is a hard one, guys. I made this question based on a UK Chemistry Olympiad question. So this is a scientific, there's no, issues in science. And not a fabricated question, okay?
Oh, Florida.
What does option D say?
Option D is Ca9, carbon 12. It's too small for you to read?
Yeah, kind of.
Okay. It's Ca9, carbon 12. But option D. Okay, not bad. So here, there is a carbide anion, which is made by 2 carbons. Actually, it is Ca2 2 minus. Ca2 2 minus. So this is a group, right? So for option B, you just need to simply count the atoms one by one, but you didn't consider this is a unit cell. What does a unit cell mean? It is repeating. That means it's not a single structure. This is just the repeating unit of this 3-dimensional big, crystal. So basically, the atom in the corner is shared by 8, cubes like this, right? That means you need to use 8 red ones times 1/8, and you have 1 in the center of the cube. This is kind of called the body center, right? So similarly, you can also count the anion. So there are 4 in each, edge, but only in the z-axis, not in any other x and y axis. So each of them will be shared by 4 cubes. So it's 4 times 1/4. And you also have 1 here, another 1 here. This is on the top face, and the bottom face is in the face center. So you got 2 in the face center, but each face center is shared by 2 cubes. So 2 times 1/2. So you got a 1 plus 1, you got 2. So here you also got 2. So the formula is CaC2.
I think there was a typo in the question that said it contains only calcium and oxygen.
Oh, my bad. It should be calcium and carbons. Yeah, thank you. This is a typo. Okay. Oh, my bad. This also should be CaC rather than CaO. Okay. Yeah. The Kahoot code is in the right bottom of this page. Did you see that? Is A2 A6019. I believe you guys can all see it, right? Let me still put it here. Okay, guys, let's continue. Guys, we'll now take a break. If we finish earlier and you guys have no further question, we can end a little bit earlier. My plan is to end no later than 9 o'clock, okay? Right now, we are in the right position. Pretty good, guys. This is the combination of quantum numbers and ionization energy. First, you need to realize, the 300 means a 3s orbital, and 31 means a 3p orbital, right? So obviously, we can eliminate 3s first, because 3s is the inside compared to 3p. So for 3p of sulfur and phosphorus, based on the trends, the general trends of the ionization energy across the period, right? The ionization energy is increasing due to the increasing effective nuclear charge. But if you pay attention to the ionization energy of the second period elements, there are two exceptions. The first exception is for the element in the group 6A. That means for NS2, NP4, compared to NS2, NP3. So this one actually is smaller. This one is smaller. The reason why, if you draw the electron configuration, I think you will figure out. This is the 3s2, this is 3p4. So this electron actually is paired, is squeezed in a orbital with another electron. So this one is relatively easier to be ionized or to be removed. And for the NS2 NP3, since each orbital is a kind of half-filled electron configuration, is relatively more stable. So this electron will be harder to be removed. So you will see there will be a decreasement in the general increasement trends in two places. So one is here, is in between the P3 and the P4. Another one is here, is in between the P0 and P1. So basically this is S2 P0, this is S2 P1. Last 10 seconds. This is a hard question. It's indeed hard, right? So if you finished the local 2021, you may know there is a similar question asking about the oxidation number of the sulfur in the thiosulfate. So this is why I wrote this question, similar, but a slightly different story. In order to figure out what is the oxidation number for each sulfur here, we need to draw the Lewis structure. So we know the Lewis structure should be like this. Now this makes sense to you guys. I didn't draw the lone pairs on the oxygen, but you know there are some lone pairs, right? For the double bonded oxygen, there are 2 lone pairs. For the single bonded oxygen with a negative charge, there are 3 lone pairs. And then if you count the formal charge of each sulfur, both of these 2 are 0. So this is a reasonable Lewis structure. Let me know if you can draw a better one. And then based on this one, we can further analyze the oxidation number, right? For oxidation number assignment, we suppose the more electronegative atom will take all of the bonding electrons, right? The less electronegative atom will lose all of the bonding electrons. So this is why in HCl, although this is a covalent bond, we will say the chlorine is -1, the hydrogen is +1, because we suppose this one shared electron pair completely goes to chlorine, right? So here, based on this logic, we will say this oxygen will make the sulfur 2+, right? This oxygen will make the sulfur 1+, because there's only one single bond in between the sulfur and oxygen, right? The oxygen is still -2, but another negative oxidation number is caused by the negative charge, right? The negative charge. And this SS bond is supposed to be nonpolar, so which means it will not give the sulfur any oxidation number. It is kind of 0. This is similar to the oxidation number in hydrogen peroxide. The reason why hydrogen peroxide, the oxygen is -1 is because this bond is polar, but this bond is non-polar. So both are 0 for this bond. So -1 comes from the positive hydrogen, right? So here I will conclude the overall oxidation number for the left sulfur is +3. So I think if you use a similar idea to analyze the second sulfur, you will get the results, right? It's supposed to be +5. So one is +3, another one is +5. So the average is +4, which is consistent with the formula because oxygen is supposed to be -2. And then the overall oxidation number, the sum of all of the oxidation numbers equals to the charge of the ion. If it's a neutral compound, it's supposed to be 0. I'm talking about the sum. Makes sense, right? This is supposed to be an easy question. I didn't expect, many students actually got wrong. So as you can see, there is a significant increasement in between IE4 and IE5, right? That means there are 4 valence electrons. The reason why the 5th one is so high is because it starts to take away the inner electrons, right? So if if there are 4 valence electrons, the oxidation number of the common oxidation number when it binds with oxygen is supposed to be +4. So the formula should be XO2. Makes sense, right? Yeah, we have about 8, maybe 9 more questions.
Hey Google, give me a 15-minute timer. Second timer for 15 minutes, starting now.
Okay, pretty good. This is the complex, or you can say a coordination compound. The carbon monoxide is the neutral ligand here. When I say ligand, it means it can donate the lone pair to the central metal, right? So this is the Lewis structure of carbon monoxide. So the carbon, which has a lower electron activity, also with a lone pair, can donate to the central metal or metal cation with the empty orbitals. So this is called a coordination bond. Basically, the difference between a coordination bond with a regular covalent bond is A atom 1 provide 1 electron, atom B provide another electron, they share the electron into a pair, right? So here is the ligand provide a lone pair, but the central metal provide an empty orbital. So 1 + 1 is 2. Here, 0 + 2 is also 2, right? This is called a coordination bond. So since the carbon monoxide is a neutral ligand, so the cobalt here is a cobalt atom. So we know based on the location of the cobalt, it's just after iron. And iron is 3d6 4s2. I recommend you remember the 3d6 4s2, which might save you a lot of time when you do similar analysis. And then cobalt will be 3d7 4s2. That is option A. But if the ligand has charge, you need to analyze the oxidation number of the central metal first, and then you can further figure out what is the electron configuration. Remember, carbon monoxide is a neutral ligand. Okay, this actually is a pretty challenging question. First, we need to eliminate both A and D because both of these two is magnesium 1 plus, is a magnesium cation. So taking away one more electron from a cation definitely is much harder because this is the second ionization energy of magnesium. And for B and C, they are both the magnesium atom, which will be much easier, right? And C is the excited state, and B is the ground state. The excited state has a higher energy, right? This electron has a higher energy than the 3s electron, which will be easy to be removed. So this is why C has the lowest ionization energy. So if we slightly change this question, guys, let's say if we ask which one has the highest first ionization energy, what would be your answer? Can you type your answer in the chat box? Which one has the highest? A lot of you chose A. Any different opinion? The highest. I think there's no problem for the answer to be A, right? Compared to D, A is a kind of a lower energy state, right? So it will be harder to remove compared to D, right? And we can eliminate B and C first. I like this question. I think it's pretty good. Last few seconds. Okay, pretty good, guys. NO actually has a 2.5 bonds, right? How can we get it? Actually, I recommend students to think about from this perspective. You can compare NO plus and NO minus, and you will see NO plus actually is the isoelectronic species with N2, right? Isoelectronic means they have the same number of valence electrons. So N2 nitrogen gas has a triple bond. So NO plus is also a triple bond. The oxygen carry a positive charge. NO minus has a, I think it's the isoelectronics with O2, right? We know O2 has a double bond. So here we can put a double bond here and put the two lone pairs for each and then put a negative charge on the nitrogen. This is NO minus. So NO is in between the NO plus and NO minus. So the bond order is also in between, which is 2.5. Obviously, you can use the molecular orbital to show the molecular orbital diagram and use the number of bonding electrons minus the anti-bonding electrons divided by 2 to get the bond order, basically how many bonds. But this can be a more straightforward way. So similarly, NO2 is also a odd electron species. You can use a similar strategy to calculate the bond order. It is supposed to be 1.5. And I think CD are relatively easy to be eliminated. So unless there is a NO plus with a triple bond, there is no stronger bond than NO here. Regarding the recording of this session, guys, I need to take some time to double check, make sure there's no issue or no problem. No one's face is included in the video. If everything is okay, I will post the video link in my website and also in my Discord server, okay? Probably tomorrow or the day after tomorrow if you miss any contents in the beginning. Wow, this question seems harder than expected, right? SO3, as you know, you can draw the Lewis structure, 3 SO double bond, no more lone pair on the central sulfur. So the bond angle is supposed to be 120 because this is the trigonoplanar structure, right? SO2, as you can see, there's one more lone pair on the sulfur, but we know lone pair is fat, right? It can provide a larger repulsion force to the bonding pairs. So the bond angle here is supposed to be smaller than 120. Let me double check, okay, guys? I think my analysis is reasonable. So this is what we can get based on the VS-EPR model. Yeah, it's 119. Wow, it's so close. The reason here is not that small is because the lone pair is not significantly more repulsive compared to a double bond, right? If we analyze the bond angle in water, in ammonia, we can easily say the lone pair is much bigger or can provide a much larger repulsion to the single bonding pair. But here, they are both, double bonded pairs, right? But still, lone pair is a lone pair. Lone pair is the strongest. So back to the question, SO4 2 minus, which is the last one, is a perfect tetrahedral structure. So the bond angle is supposed to be 109.5. SO3 2 minus is something like this, but don't forget, there's one more lone pair surrounding the central sulfur. Remember, sulfur is supposed to have 6 valence electrons, right? You always want to show the 6 valence electrons. So now I think the geometry of this anion is supposed to be trigonopyramidal. So the bond angle is supposed to be smaller than 109.5. So the answer is A, SO3. 120 is the largest bond angle. Last 15 seconds. Indeed, it's a hard question. So I didn't put any title to this question. I put a question mark because I don't want to give you the hint. The question actually is about molecular orbital theory. This is what I got from the recent local exams. They want to assess you molecular orbital theories, but they try to avoid the keywords in the question. They want you to know, use the molecular orbital theory and to explain or to analyze a molecule or some bonds,
Alexa,
right?
Hey Google, stop.
So here, SO is isoelectronic with O2, right? So it's supposed to have a similar bond order with O2. So that means if you draw a Lewis structure, it's supposed to be like this. And then based on the molecular orbital diagram, it's also supposed to be similar to O2. And you guys know O2 is a paramagnetic species, right? Which means it has unpaired electrons. There are two unpaired electrons. So here, I do not have time to give you a full introduction of molecular orbital theories. You can get a little bit more from the annotations we made. You may also read more detailed information from Google. You just search molecular orbital, or you can search YouTube. I think you will get some very good videos. I believe in my YouTube channel, I also have a maybe 70 minutes to 90 minutes, very detailed introduction to the molecular orbital theories and also the related applications. Try to find it from my website. Okay, I cannot give you the link right now. So let's briefly draw the molecular orbitals. Let's just show the p parts. So we got 3 bonding MOs and 3 anti-bonding MOs. Bonding means lower than the atomic orbitals. Anti means they're higher. And we know for sulfur and oxygen, they both have 4 valence electrons, right? Not 4, sorry, 6, but 4 on the P subshell. I add too many. Yeah, both have 4. So we have 8 in total. So when we put the 8 electrons here, we will get a result like this. So there will be 2 unpaired electrons. So only with the molecular orbital theory, we can explain the mechanism of O2. So here is a quite similar stuff, right? SO.
So I'm pretty sure it doesn't exist.
It exists. Is this not fabricated me? I did some research, okay? It existed. This is called sulfur monoxide. It is an inorganic compound with formula SO. It is only found as a dilute gas phase, but it existed. Okay. Thanks. Okay, guys, the last few. Oh, this is pretty hard question. I'm very glad, 9 students actually got it correct, okay? Let me see. Okay, let's draw all of the isomers. This is a metal with A2, B2, C2, right? So we can use ABC to simplify our drawing. So I think we need to have some systematic strategy because this is the octahedral structure, right? First, we can try to make AA in trans. That means they are on the opposite side of the central metal cation. And BB in trans, CC in trans. I think this is the first one we can think about. And then we can put one of the ABC in trans, let's say AA in trans, but BB is not, BB and CC are not in trans, they are in cis. Cis means they are on the same side of the metal. And obviously we can times 3 for this scenario because we can replace the AA in trans into BB in trans and the CC in trans, but all of the other two are in cis, right? Lastly, I think we can put all of them in cis. So that means AA is here, BB is here, CC is here, right? Yes, all of them are in cis. So it seems like we only got 5. Why the correct answer is 6? The last step you need to confirm is whether there is any structure is chiral, which means it is not superimposable with its mirror image, right? If it's not superimposable with its mirror image, the structure will be different from the mirror image. There will be one more isomer, right? This is called a stereoisomer or optical isomer. But drawing the mirror image and compare the mirror image with the original structure to see whether they are superimposable is very hard. Sometimes it's misleading. So an easy way is to analyze the symmetric elements in the structure. So the idea is like this. If you can find any plane symmetry or central symmetry in the structure, that means this molecule is not chiral or is achiral. That means it will be superimposable with the mirror image. But if you cannot find both the plane symmetry and the central symmetry, that means the molecule is chiral. It is not superimposable with the mirror image. So I think the last one, the all cis one, is the chiral one because you cannot find any plane which can make the molecule symmetric. You cannot find any center to make the molecule symmetric. So I will leave the time for you guys, leave this as a homework for you guys to further analyze. You guys can try to draw its mirror image by adding a mirror here and draw the mirror image by yourself. And then try to rotate these two molecules, rotate one, and you try to make it superimposable with the original one. I don't think you can make it, but I think you probably need to take a little bit more time to work on this. So the final answer is 6. For the other 3, you can easily find a plane to make the molecule symmetric. For example, this one, this is the plane because the top one and the bottom one are the same, okay? Remember, this is the octahedral structure, okay? I hope I made it clear. If you have any further question to any of the questions we discussed in this packet, feel free to ask me in Discord, okay? Okay. I think we can try to flip the right structure, and we flip in this way. And this one after it flipped, it will be towards up. This one after it flipped, it will be towards down. And then you will see the new structure, this one after flipping, is exactly the mirror image of the original structure. That means these two structures are mirror images relationship, or you can say they are enantiomorphs, sorry, enantiomorphs. The meaning of geometric means cis and trans, okay? For an alkene, if the two groups are on the same side, it's called cis, on different side, it's called trans. Or if you have another structure, as Nat said, if you have another structure like this, so these two, I will say they are geometric isomers because this is the one called trans. The two methyl groups are on different sides of the ring. And this one is called cis. The two methyl groups are on the same side of the ring. Oh, compounds, I have two. Oh, there's a typo here. I shouldn't be okay. It will now affect your understanding. This is indeed a hard question, right? Aldehyde with the formula of C3H6O1 has a structure like this, right? This is the skeleton structure, 1 carbon, 2 carbons, 3 carbons with a CO double bond. And the hydrogen here is very important because it's an aldehyde rather than a ketone, right? So first, all of the aldehydes has a very special order. You can think about the formaldehyde, which is, an air pollutant, especially the indoor air pollutant. After a new house was just painted, there's always some kind of level of formaldehyde in the air because the formaldehyde is commonly used in the pigments, in the painting materials. Boiling point greater than 100 degrees Celsius is not right because there's no hydrogen bond similar to the ethanol or the carboxylic acid. So for a 3 carbon organic molecule, the boiling point it will not be higher than 100 degrees Celsius. Even ethanol with the hydrogen bond has only 78 degrees Celsius. So actually, this aldehyde, its boiling point is around 20, maybe 22 degrees Celsius. No reaction with Cr6. Chromium 6 is a strong oxidizing agent, so it can easily oxidize the aldehyde into a carboxylic acid, which will be the propanoic acid. Okay? Aldehydes are very easy to be oxidized. Water solubility less than 10 grams per liter, this is wrong, because although the aldehyde cannot make hydrogen bond with each other, but it can make hydrogen bond with the oxygen. So this oxygen here can make hydrogen bond with water. So this is why it is supposed to be relatively soluble. Actually, I believe this aldehyde probably is miscible in water, or at least a pretty big solubility. A very interesting question, right? So the answer is A. Guys, let's finish the last question. I think I can finish in 2 minutes. If you guys can submit your answer a little bit faster, I think we can save some time. Thank you. So this question actually is not supposed to be hard. The reason why C is incorrect is because the esterification process is a dehydration. So it needs to be catalyzed by acid rather than base. If you use a base, the acid will be neutralized and changed into the carboxylate. And the carboxylate cannot do a dehydration with the alcohol anymore. For option A, this is a nucleophile. It can attack the CH3 and push off the Br-, which will all give you the same ester as well. So both A, B, and D are good ways to produce the esters, but C is not the right way. And for B, it's slightly more complicated. This stuff is not an acid, it's called acid anhydride, which means it is 2 acid molecules loses 1 water molecule to get this acid anhydride. So it's kind of a equivalence to the acid. Actually, it is even better compared to the acid for the esterification process because it's more reactive. So the answer is C. Esterification is very important. It's a must-known organic reaction. If you need to know only one organic reaction, it should be esterification. It's pretty much assessed every year. Guys, check the lecture note I show you in the beginning, the one I posted, in the ACS website for the US INSEAD coaching session last year. Okay. Last one. Okay, a lot of you are struggled with the D option. Actually, sulfur is in the proteins because among the 20 common amino acids, there are at least 2 of them with sulfur inside. So this is why. Yeah.
Cysteine and methionine, right?
I think so. Yeah. So this is why for the poop of like deers, cow, and goats, they are not so smelly because they only eat grasses. Right? They only eat grass. And in the grass, there's no, proteins, right? Or very little proteins. And they are called herbivore, right? But for dogs, for cats, for human beings, their poops are very smelly, right? Because they are omnivore, they eat meat, they eat proteins. And in the protein, they sulfur, the sulfur element. And then after digestion, the sulfur is released from your body, changed into some very, smelly gas, such as H2S, hydrogen sulfide, right? Okay, yeah, that's everything, all of the questions. I think I covered all of the non-calculation based topics. I hope you enjoyed the practice with me tonight. And I hope it's also helpful to you. So here, there are a few more resources I would like to share with you. If you want to learn more about descriptive chemistry and the laboratory, I have a pretty good summary in my website. Just want to quickly show you. Go to dcho.us. If you go to USNCO laboratory, I had a pretty good summary about the key points of the important laboratory and also the YouTube videos, not made by me, but made by the others. But I think among many YouTube videos corresponding to a certain topic, I think this one is the best. At least I pick up the best I can see. So there are a lot of experiments listed here. And then I also have a very brief summary or some key points for each laboratory. I have around 10 labs done, but I probably need to finish another maybe 6 or 8. I will try to see what I can make for the local exam. But I believe those videos, those summaries are also useful for the national exam. So hopefully I can make them down before the national exam. So
why are they all time lapse of a cold winter day at the bottom?
What that?
Like they're all time lapse of a cold winter day at the bottom.
I didn't see that.
They go down, like the videos.
Oh, this is just a sample here. That means I didn't work on this yet. This is the template from the website. Yeah, another one, guys. You may know the National Part 3 is back this year. So there is a USN webinar organized by ACS to give you more information about how to prepare for the national exam Part 3. So where can you find the link? You go to USNCO, the home link, and then which is here. This is the information for the webinar. It will be on March the 10th, 2022 at 7 p.m. Eastern time. You can register the webinar and then you will get the invitation and the link for the webinar. So I think this is the first time for ACS to give some introduction about the Part 3. I think it's worth to listen. The last one, a little bit of advertisement. I'm going to have a national prep classes in April, in early and middle April. So the detailed information can also be found, from my website. If you go to, let me see, yeah, classes information, which is here. So I'm going to have an 8 session, 1.0 hour for each session, classes for the national preparation. I know, you didn't take the local exam yet, so you probably don't know whether you will be nominated or not. But in case you are, I hope you guys are all, are nominated. So if you, want to do more preparation with me, I think this can be a, good chance to further boost your preparation. National exam is much harder than the local exam. So I will mainly focus on the most advanced topics in each category, such as descriptive chemistry, organic chemistry, and also some advanced kinetics, electrochemistry, equilibrium, and also some structure stuff, such as molecular orbital series. So we will start on April the 3rd. And I believe this is I will have 2 sessions per week, I believe. This is the syllabus. Yeah, I think so. It's both on Saturday night and Sunday night, except the first session and the last session. Yeah, guys, let me know if you guys are interested. If you want to know more details about this class, you can talk with me in the Discord server. You can also send me emails. Guys, once again, if you have any question about the packet we practiced today, let me know, okay? I think I can make it public. I will share the link with you guys maybe tomorrow or the day after tomorrow for you guys to practice by yourself. If you want to go over some of the questions with a little bit more time, I think you can do that. Before we end, do you guys have any last minute question for me? I apologize, we kind of used a little bit more time than I planned. If now, Oh yes, you need to have the verification. You can say something in the instruction channel, and then I will put you in. Okay. Okay, great, guys. Thanks for your participation. I wish you the best luck in the coming local exam. I hope I can see you in the national prep class. Bye bye, guys. Have a good night.